Welcome, my name is Randy Peterson. This video covers hand and power tool safety. Maintenance makes up 8% of the WM recycling workforce and accounts for 30% of the OSHA recordable injuries, these generally being more severe injuries. Waste management recycling averages 8 OSHA recordable injuries per year related to hand and power tools. Over 50% of maintenance OSHA recordable injuries are related to hand and power tools. The most common injuries from working with hand and power tools are electric shock, flash burns, falling, hand and eye injuries, hearing loss, crushing, cuts, or losing a body part, and ergonomic injuries. The PPE matrix outlines minimum PPE requirements for different job tasks. At the bottom, there's an information key that identifies PPE that is required, wear when appropriate, and specialized PPE. Refer to your PPE hazard assessments for further details on the pieces of personal protective equipment or its use. All employees need to wear safety-toed boots, work uniform, high visibility vest, hard hat, safety glasses, and gloves. For the grinding task, you need to wear a face shield, where appropriate, hearing protection, and dust mask. Scissors boom lift, specialized PPE would include fall protection. What do the regulations say about hand tools? Employers shall not issue or permit the use of unsafe hand tools. Wrenches, including adjustable, pipe, end, and socket wrenches, shall not be used when jaws are sprung to the point that slippage occurs. Impact tools, such as drift pins, wedges, and chisels, shall be kept free of mushroomed heads. The wooden handles of tools shall be kept free of splinters or cracks and shall be kept tight in the tool.
So some basic tool safety rules. Keep the floor surfaces where you're working free from debris and tripping and slipping hazards. That's very important when you're working with hand tools. You want to make sure that the area is clean. Keep your cutting tools sharp. Inspect your tools before each use and use the right tool for the job. Operate each tool according to the manufacturer's instructions. Use the right personal protective equipment for the job. And make sure you look at and review your PPE matrix for your site for the job and the task that you're doing. And always use proper guarding on every tool. For cutting and slicing tools, including knives, box cutters, utility knives, scissors, and razor blades, knives cause more disabling injuries than any other hand tool that we use. The hazards are that the hands may slip from the handle onto the blade, or that the knife may strike the body or the free hand. Use knives with handles and guards if possible. Knives should be kept sharp and in their holders, cabinets, or sheaths when you're not in use. The cutting stroke should always be away from the body, never towards you. Here are some tips for using utility knives safely. Only use utility knives and blades that were provided by Waste Management. Do not use knives and blades and scissors from home or that you found on the line. And here's some examples of that. We've got some scissors, a wore-out knife. Common is one of these knives that was found on the line. Do not use these. Make sure they're discarded safely. Check the work area to make sure it is suitable. Is there enough light so you can see what you're doing? Is there enough space to work safely? Is the area free of distractions that could cause an accident? Focus on the task. Pay attention while you cut. If your mind wanders even for a moment, you could be cut. Make sure the handle offers a good grip. Wipe it down first if it's wet, oil, or tacky. make sure your knife blade is sharp. A dull knife is more dangerous than a sharp one, as it's more apt to snag and pull and making the cut less controlled. Make sure the blade is properly seated in the knife. Also, if you're working in a lowered position, make sure you're wearing your knee pads. Keep your free hand, forearm, and the rest of your body clear of the cutting path. Always cut away from yourself. This is an obvious point, yet it is the most common reason for accidents. When using a knife to cut through thick material, make several passes, cutting a little deeper each into the material with each pass. Do not use blades as screwdrivers to pry something open. Blades are brittle and can easily snap. Never carry an exposed knife around in your hand. If a knife slips out of your hand, don't attempt to catch it. There's no guarantee you're going to catch it with the handle. Dispose of dull or dirty blades in proper receptacles. If you need to change the blade, pull out the blade from the dull side and slide a new one in at the top of the holder. Keep box cutters, knives in proper storage areas with the blades retracted when not in use. Use of disposable knives with breakaway blades are not meant for industrial use. Stay away from them. Here's an example of a breakaway blade. As a reminder, never use scissors in our application. When knives become overly used, dispose of them properly. Knives without retractable blades should never be used. And again, never use anything that was found on the sorting lines. A screwdriver is the most commonly used and abused tool. The practice of using screwdrivers as punches, wedges, pinch bars, or pry bars is discouraged, as this practice dulls the blades and can cause employees injury. Screwdriver tips should be selected to fit the screw. Sharp edge bits will not slip as easily as dull ones. Redress tips to the original shape to keep them clean. Always hold work in a vise or lay it flat on a surface to lessen the chance of injury if the screwdriver should slip. When working near electrical equipment, screwdrivers should be equipped with insulated handles. Some also come with insulated blades. Here's some examples of commonly used screwdrivers in our industry. We have screwdrivers with replaceable bits, wooden handles, and you can see that you want to make sure that these screwdrivers are very sharp so they grab the fastener. Here are some screwdrivers that we shouldn't use. Screwdrivers with bent blades, a screwdriver that's been modified as a pry bar. These should all be discarded and not used. Now we're going to talk about hammers. Wooden handles should be straight grained and free of slivers and splinters. Once split, handles should be replaced. Make sure handles are tightly wedged. Here's an example of a sledgehammer with a wooden handle, and you can see the straight grain. Here's a machinist hammer with a wooden handle. This one's got a slight chip on it. That should be replaced. And always check this and make sure these are tight. Some other hammers that we have here are a dead blow hammer, ball peen hammer, chipping hammer, and never strike a hammer with another hammer. Discard any hammer that shows chips, dents, and redressing is not recommended. Safety glasses should be worn while using a hammer or any other striking tool. Never use a common nail hammer to strike other metal objects such as cold chisels. And always make sure the handles are clean and free of grease to prevent the tools from slipping out of your hand when in use. Wrenches come in an endless variety of styles, such as a socket, an open end, in combination, an adjustable, and torque wrenches, just to name a few. Wrenches are designed to turn or hold bolts, nuts, or multiple threaded fasteners. They are sized to keep the leverage and the load in an acceptable balance. Choose a wrench that properly fits the fastener you wish to turn. Use metric wrenches for metric bolts and American inch wrenches for inch-sized bolts. By using the correct size, the wrench is less prone to slip or round off the fastener's corners. Avoid using cheater bars to improve the leverage of a wrench. Do not use open end or adjustable wrenches for final tightening or loosening of frozen fasteners. These wrenches do not have the strength of a box end or a socket wrench. Apply penetrating oil on frozen fasteners before using a striking face box, socket, or heavy-duty box wrench. Do not expose a wrench to temperatures that could weaken the tool hardness. Always try to pull on a wrench instead of pushing in case the fastener loosens. Adjustable wrenches must be adjusted tightly to the fastener and then pulled, putting the force on the fixed end. Turn power off and use electrically insulated wrenches when working on or around electrical components. Never alter a wrench. Do not over-torque a fastener. Use a torque wrench to tighten the fastener to the exact torque required. Use torque chart for proper fastener tightening. See fastener torque chart. Inspect wrenches before each use for damage such as cracking, severe wear, or distortion. Never use a damaged wrench. Pliers come in all shapes and sizes, such as lineman pliers, diagonal cutters, such as these, needle nose pliers, such as these, extended nose pliers, slip joint pliers that have a locking mechanism, and just regular slip joint pliers, like these. We also have electrician pliers here for stripping wire and crimping, and locking pliers. Those are probably the most common that we have. We also have the smaller version of Nipex, little mini bolt cutters. Pliers used including gripping, cutting, turning, and bending. Pliers are very versatile, but must be used according to how they're designed. Do not increase a plier's handle length to increase the leverage, such as this. That's never a good idea. It's not safe. Something we shouldn't do. Never subject pliers to temperatures that could decrease the tool hardness. Don't heat them. Don't bend them. Cut hardened wire only with pliers designed for that purpose, such as these mini bolt cutters or Nipex. These work really well for this wire here. So, and that wouldn't work real well with something like this, right? Because you don't have the leverage to make that happen. Do not substitute pliers for a wrench when turning nuts and bolts. You're just going to damage the fastener and hurt your hands when they slip. Be sure that the plier's jaws can grasp properly when bending wire. Make sure that you've got something that actually is pretty firm. So when you're grabbing onto a piece of wire to bend it, it won't slip. You want to be able to just hold that and bend it right over. Do not hammer with a pair of pliers. These aren't designed as an impact tool. So you'll just damage the set of pliers and maybe cause an injury. Cut wire at right angles without bending the wire back and forth. As you can see, you just want to be able to take that wire, again, hold it, and cut it. You don't want to have to take the wire and bend it back and forth to break that wire off. That's a sign that you're either not using the right tool or the tool is damaged. Now we're going to talk about pry bars. Use the proper kind of pry bar for the size of the job. We've got several different kinds here laid out in front of us. One of the things you want to remember is never use a makeshift such as a piece of pipe for an extension on a pry bar. There's really no way you can control this when you need to put this on, and it's just going to slip and cause an injury. So that's never a good idea. Pry bars need to have a point or a toe in such a shape that it'll grip the object to be moved, and a heel to act as a pivot and a fulcrum. So as you can see on all of these pry bars, each one of them has a heel here and a point. And this is where the leverage is brought in, right here. So make sure when you're inspecting them that this is in good shape, the heel's in good shape, it's not bent or twisted or damaged in any way. And make sure you're inspecting the handles. Some pry bars have grips for handles, some are just steel. Let's make sure you're using the proper tool for the job. Never use a screwdriver as a pry bar. These are intended for a purpose of extracting screws and tightening. They're not hardened enough, they'll break, and they're not a very good tool for a pry bar. And then inspect each pry bar before each use. Make sure that when you're looking at the pry bar that it's straight, it's not bent, the heel's in good condition, and it's not wore out on the end. As you can see on this one here, it's got a couple things that are wrong with it. This should be turned in and removed from service. We talked a little bit about using the right pry bar for the right job. This is a pry bar that you would see in the carpentry, with wood, pulling nails, and along with these. They've got a long sweep. It still does have the fulcrum and the toe, and we do use this kind of crowbar in our application. And we've got some other ones here called crow's feet with a pointed end and a large fulcrum for gaining a lot of leverage. Not for a lot of big jobs, but it is something you're going to see. And just make sure that you're inspecting them before each use. Make sure they're not cracked or damaged, because you're pulling on this to move something, and if it was to break or shatter, you're going to lose control and you could have an injury. Now we're going to talk about air gun safety. The pressures necessary to remove the particles from machines and surfaces is also strong enough to blow them into the eyes or ears or skin of the nearby people. The greatest danger in dusting yourself down lies in an accidental internal injury to the body. Compressed air can enter the body where the skin is not present and can cause the affected part to swell to an alarming proportions and be accompanied by severe pain. If the air gets into the bloodstream, it can make its way to the small blood vessels of the brain, burst the vessels, and potentially cause death. A pressure strong enough to dust or clean is strong enough to breach the skin and penetrate the body. Even pressures as low as 5 to 10 pounds per square inch, or PSI, can cause serious injury. Due to the serious injuries that can be caused by compressed air, OSHA requirements pertaining to the safe use of air guns for cleaning purposes focus on pressure and chip guarding. The federal OSHA requirements can be found in 29 CFR Part 1910.242B, which states, compressed air should not be used for cleaning purposes except where reduced to less than 30 psi, and then only with effective chip guarding and personal protective equipment. This regulation relates to cleaning objects or items only. The phrase reduced to less than 30 psi means that the nozzle pressure or opening of the gun, pipe, cleaning lance, used for cleaning purposes will remain at a pressure level below 30 psi in the event the tool is dead-ended, meaning if the tip of a gun is blocked. You can see that we've got several different air wands here that are very common in our facilities. We've got some good examples and some bad examples. This is a lance, an extension with the chip guard in place. The chip guards will have holes on the perimeter of the nozzle. It's very important that these are here. So when the tool is put down or deadheaded, the air has a place to escape. That's what those are for. As you can see here, we've got some tools. This is one that's in really good condition. Here's a wand that was used for some other purposes. It's missing the nozzle. It's been bent. This should be taken out of service. And a lot of these will unscrew, and you can just replace the pipe end or the extension. Here's another example. It's got the nozzle on the end. As you can see, though, it's been wore out. It's been used as when they're cleaning, they'll go in to use it to move material, and what's happened is it's broken the end of the tip off. So this nozzle is not compliant anymore, so it would need to be removed. A lot of these nozzles do unscrew, so you don't have to get a whole new gun. You can just purchase the nozzle and replace those. That's something that you want to look for when you're going through your facilities and using them. Very important. Here's a nozzle that you might see in your facility, just a little nozzle. It's missing the chip guard. This is something that if you do see it in service, remove it from service and get a chip guard on it and make sure that it's compliant. A couple other things you may see is sometimes you'll find that the holes in the nozzle have been covered. Sometimes they're plugged with debris, sometimes it's tape. Again, this nozzle, if I was to deadhead the pressure against that, the air would not have any place to go, or it's going to eventually come out the sides here and may injure you. So let's make sure that we're using the correct nozzles, they're in good shape, and we're compliant with the regulations. Scott, what do you got to add for air hoses for us?
Well, thank you. That's a very good point, Chip. Whenever you use an air gun or any type of air tools, always check your air holes. Make sure there's no cuts, and the air holes in very good condition. Always check your connection. Make sure there's no sharp edges at all that you could cut your hand on it. And prior to putting an air tool into the quick disconnect, this particular air quick disconnect relieves the pressure prior to putting on your air nozzle and take it off. As you can see, there's no air pressure as I'm putting the unit on, and then you twist this small lever down on the bottom, and then all of a sudden you have air pressure. You cannot disconnect this without removing the air pressure prior to removing the air tool. It's a very good safety tool, especially with compressed air. Here's a particular air quick disconnect that you can purchase from Grainger. In the video, you will see the part number where you can purchase this, and I strongly suggest that you change all your air nozzles over this particular quick disconnect.